Good afternoon, ladies and gentlemen. For the last several centuries, now, for the last several millennia, humans have been convinced that they're the greatest, best, smartest critters on the planet. Now, you could be forgiven for their hubris, our hubris, because we've done some pretty great things. But of those, I think the most undervalued skill that we have demonstrated is the ability to abstract information, to boil a messy, noisy, complex world down into simple thoughts, logic that describes it. That you could stitch this together in books, in science, in mathematics, and build complicated, intricate simulations of the world. That we could solve pretty much any problem with the technology we've built. As the Second World War finished and the heady days following that, the computer had just been invented. It had shown the ability to do somewhat simple things like calculate the trajectory of ordnance. But there were a few researchers who saw something there. The idea that you could take these logical operations and automate them. Gone was the pencil and paper to do this work, but now to compute them in these machines and vast arrays of instructions. And that the idea that there were some problems, hey, most problems, that could be solved with this automated logic. Take a children's game. Chess is made up of some fairly simple steps from different pieces. Human language, you can take simple declarative statements, Jane saw the cat. Certainly we could parse that. And the rest of it, robotic control, seems so close. In the 1950s, the perspective was 10 to 20 years tops. We'll have this nailed. As the years progressed from that idea, rich languages were constructed. You can argue that this is the apex of logical thought. Languages that can describe virtually any problem, any complexity problem, and solve them. Challenge is not with the languages. Challenges is with the humans that have to build and maintain these systems. These have brought us two issues. One, the systems have become so complex and so intricate that our creators, are challenged with an ability to make them more complex. And second, when you boil things down into logic, you start to view things as these systems are designed, to view it in true and false, black and white, yes and no. That the world and computers themselves always gave us perfect, oracular answers that were true and false. We know the world doesn't work that way. But we trained our systems to do it, and we started to believe that that was the right answer. But the world is a little more complex than that. Chess, for all of its complexity, is 120 orders of magnitude less complex than the game of Go. Arguably, humans should not be able to play the game, but they play it, and they play it quite well. Simple statements like, this statement is a lie. Logical systems can't handle that. It's called a logic bomb. You laughed when you saw that. Why did this self-referential statement not mess with your brain? Or take this one. You hand that to a logical system, it will give you an answer. Anyone here who has been married for a few years knows darn well there is no answer. Your best response is to say, I didn't hear you, I will go wash the dishes. Or what about the visual world? The complexity of the visual world is a mess. It required a new approach. The logical systems that we were so proud of reached their limit. All of those great projects that we thought would be done in decades were dashed on the rocks of complexity. And we came back to this bizarre little beastie, a neural network. Brainless, tiny, logicless connections of summing junctions. You can run some numerics and some math packages to figure it out. This is an example of one, an unreasonably simple one, that does human handwritten digits. You can look at those on the left. Some of those I have trouble reading is the number 6. But you can see the nodes light up with the different types of handwriting and whatnot. I don't know what any of those nodes do. No one does. No more than I know the neurons in my head that match the number 6. I just know that if I train inputs, and tell it outputs, it will be trained and it will be highly accurate. We have traded a system of handwritten logic, intricate, proud logic, for a training system, a learning system that works much like we do. We have an issue with this. We love the fact that we can look at code, stare at a line, and say, the bug is there. I know why it failed. When I look at neural networks, I can no longer do that. No more than I can look at my own brain and find out why I cannot tell the difference between two types of cats. Now with neural networks, you want to train cats? You don't look up the different species in an encyclopedia. You take pictures of cats. Well, luckily, the internet was built to show pictures of cats, so we have plenty of those. But it's a different mindset. No longer do you need 20 million lines of code and an extra million to add cats and an extra million for dogs. Now you just find pictures and display it. You want to train a system to identify people and cars on the street? Go take pictures of people and cars on the street. No more do I have to figure out a pattern for what a head looks like or what a car looks like. It just learns it. Learning is different. Learning is based on experience. That's how we learn. You show an example, and you say that this is the result. The problem with learning is that learning and experience are local. The experience of a young lady growing up in Nairobi will be fundamentally different from the experience of a young lady growing up in Mumbai or Atlanta. All rich, compelling experiences, a lifetime growing up there. How do I compare? If I train an AI in one versus the other, is one necessarily better or worse than the other? Of course not. But we expect them to work in all places. See, if I grew up with a lifetime of only seeing yellow duckies, it goes without saying that I'm going to design my systems for yellow duckies. I will have no idea that green duckies are important or that I need to include them in my models. Is that designer to be to blame for that? Well, I think you probably should get out a little bit more and see some more duckies. But the point is, bias is natural and hard for us to see. It is so hard for us to see out of our own worldview and accept and implement the worldviews of the others around us. It is fundamentally difficult for us. Here's an example. There's a technology company, which I won't mention the name of, that had a clever idea. They said, look, we want to figure out how to identify good job candidates. We've got 10 years of resumes. We know who we hired, who we didn't, and how well they did in their jobs. Doesn't seem too difficult. Spin up a nice deep neural network architecture. Get yourself a nice Brownian motion generator, say a nice hot cup of tea, and turn it to on. Sorry, that's a reference to Douglas Adams. What did they find? Well, it turns out the AI was very good at its job. It told you that 20% of your applicants should be female and the other 80% should be male. Is there a problem with that? Well, of course, it upset the designers until they looked at the data. They'd hired 80% male and 20% female. Oh, that's easy to fix, they said. We'll make it so it is gender insensitive. It took out its ability to see the word male or female, man or woman, or other gender-specific terms. No problem. Got the same result. Turns out that the data drove it to look, I mean, that's who they hired. You couldn't tell it otherwise. And so the algorithm identified it not based on specific terms, but on more subtle ones. Turns out men like to say that they captured things and they executed things. Turns out the female candidates didn't use those words in their resumes. The algorithm looked at the data, and it came to the conclusion it was supposed to. Sorry, that's what history had told it. The algorithm was thrown out. I mean, obviously, bad algorithm. And they'll come up with something else. But this is the problem with bias. It is extremely difficult for us to see it living in our own worldview. Training AIs is much like training children. They will absorb everything, intentional or not. So we've transitioned from logic-based machines giving us very comfortable sounding true and false statements, oracular statements of accuracy and yes and no, to systems that provide probabilities and estimates. not unlike our own brain. Systems that have best guesses. They handle complexity easily, much like we do. But they also are messy and inaccurate. Algorithmic intelligence is, frankly, more of a mirror than we expected. In fact, we can argue that algorithmic intelligence, artificial intelligence, is looking more and more human. With that, I thank you very much for your time.